Hello friends, this is Dr. Amarjeet Kaur, Professor of Accounting and Business Communication at the Department of Management, Gurugram University, Gurugram. This is my privilege that I am here with you to talk on time value of money discounting. And in this, we are going to talk about three different situations of discounting. One, that when we have uneven cash flows and we are discounting it annually. The another is that we are how to discount an annuity, and the fourth and the third situation would be discounting of a perpetuity. Why? Because we have total four situations. The first situation, the foremost important and the commonly used situation is when we have single sum and we want to discount it. That's what we learned in the previous lecture. So in this session we will be talking about discounting of three different situations excluding the single sum annual discounting. So we will begin with discounting of uneven cash flow, and we are doing discounting annually. Time period is also important. So when we are interested to know the present value of series of receipts which are received by a business or any individual at different time period in future. So you want to, for example, you are going to go for a master's program in USA. You know, the first semester you are going to study 4 courses of 4 credit each, and you would need to pay the tuition fee of $20,000 for 4 courses into 5,000 each. But in the second semester you would be studying only 2 courses, so you would need 10,000. Third semester you may study 5 courses, so 25,000, and so on. So your requirement for money is different every year, so it would be uneven. So your future value is uneven, but you want to discount it. Your dad, your mom want to understand how much should they put today that you get X amount, or these many dollars are in first year, these many dollars in second year, these many dollars in third years, right? Because your requirement is different every year, and so is possible in any business situation, right? So if we are putting up a new plant, we know in the first year we are putting up building and plant both. New factory is going to be set up. So in the first year my requirement would be this much, the second year my requirement would be this much, the third year I need to order the machinery as well, my requirement would be more. Fourth year everything is set up, but only the small few parts or spare parts would be needed, or small investment is required for AC, putting up ACs or those basic things. So your requirement as a business is different in all the next 4 years for this new plant itself. So you need to make an assessment how much should you put today. So both the example at personal level or business level which we took today, these two examples, the requirement is different, right? So we call it as uneven cash flows. Here the inflow or the outflow both are possible. So cash flows, either inflows or cash flows in terms of outflow, are different. So they are known as uneven. So how to discount uneven cash flows, right? So all that is required in this situation is to determine the present value of each individual future payment, and then to aggregate them to find the total present value of the stream of cash flows. Because I need $10,000 for 2 years from now, I need $15,000 3 years from now, I need $5,000 4 years from now, I need $50,000 5 years from now, right? So each I need to discount each future payment. So I need to make these payments, I need to discount them individually and then aggregate them or sum them up, and that is how I would come to the exact amount to be invested. So in this situation, the cash flows, the series of payments or receipts both, are of uneven amount, but they are discounted annually. We are not discounting monthly or quarterly, we are discounting annually. Therefore, we need to calculate present value of individual cash flows for all the given flows and then to have sum them up together to find out. So, the formula which we will be using here is the present value of any given amount for given n is number of year, is equal to sum of individual present value for each cash flow, or other way round we can write present value for given n is equal to summation of sigma n. Sigma n is summation of n, right? The bracket starts the future value for given time period t. The time period could be 1, 2, 3, 4, right, and it will be different every year, every time. So, one flow is 1 year from now, another flow is 5 years from now. So, future value for given t is important, multiply by the factor for that given time, right, present value interest factor for given t. And of course, given I is always there, but I would most likely be same for all the cash flows in most of the situations. It could be different as well. Since we are discounting every uneven cash flow or every cash flow independently, it does not matter, we can change I, we can change T both, right. So, we would be using the same table, the present value interest factor table, which we just discussed few minutes ago, for 1 rupee, because it is basically more than one question together on single sum discounting. I hope you are getting my point. So, more than once discounting, we are doing discounting, but for more than one principal money, more than one cash flow, and then at the end we are putting them together. So, by summing them up, so that is why the formula is summation of 9. So, this is the situation. Now, I am going to talk about a real situation in front of you, a business situation in fact. So, if I have I am expecting cash flows of 1 year from now $500 or rupees, 2 years from now 100, 3 years from now 1500, 2 years from now is 1000, 3 years from now is 1500, 4 years from now is 2000, 5 years from now is 2500. And the present value factor, if we go to the table present value factor rupee 1 table, generally it would be table 3 in most of the books, T3 we call it as T3, right. So, we have to see the column and the row for a particular rate of interest, here 10%. So, for 1 year the factor is 0.909, for 2 years factor is 0.826, for 3 years the factor is 0.751, for 4 years the factor is 0.683, for 5 years the factor is 0.621. So, if we multiply the flow, the cash flow with present value factor, we will get the present value itself. That is what we want to do. So, and at the end we are making a sum of all the values, which is coming out 5325. So, that is how it is summation of future values discounted at the rate, at the factor which we found from the table for the given I and given n. So, that is what is known, or that is the situation of discounting uneven cash flows, right, and then making a sum of them. So, this was a very important situation. It can be used in many different business situations and in personal life as well. Let us say you have to pay for any loan, you have to pay a minimum of X amount every year, you can pay anything extra. So, you decided that you will be paying this much in 2 years from now, this much 3 years from now, and so on. You want to wind up the loan before your actual allotted time. So, you will plan in a way, so you will calculate that how much you should actually save from your revenue. So, that is one application. Personal life, I have given you the example that you can save it. So, there are so many such situations where you can use it. Now, I am coming to the third situation, annual discounting of an annuity. So, let us understand that what is annuity. So, annuity is that investment or that type of cash flow which involves a series of identical cash flows at the end of each year, that's what we call it as annuity. Now please pay attention to me and understand annuity first. Annuity is basically is more than one cash flow. So that's why we call it as series of cash flows. One thing. The second thing is that amount is same, right? 100 or 1000, 10,000, 10. So the amount is same, the cash amount is same, the time is known. So first is there is a series of payment or receipts, right, of the same value, 100,000, 10,000 every time, and the n is also known. So three conditions needed to be fulfilled for anyone or for any cash flow to be known as, to be taken as annuity. I repeat, what are those three conditions? Number one, the investment is actually of same size, right? And it is not one payment, it's not one time lump sum, it is more than one payment. It could be 2, 3, 4, 20 or 2000, and it is for the known period. I know I have to make 100 payments, 100 installments, so I have to make 50 installments. So all those loans which we take for our personal use, be it car, be it a housing loan, the payments are in the form of annuity. Every month I pay exact the same amount, and I know for this for my house loan my payment is X amount, be it 50,000 or be it 20,000, and it is going to be paid till these many years, like till 2020, 2050, 2040, 2030. So n is also known. That is what is annuity. Okay. So annual discounting of an annuity, we can learn it with the help of this example. JC Incorporation purchased a tract of land on which $60,000 payment will be due each year for the next 5 years. What is the present value of this stream of cash payments when the discount rate is 12%? So let's understand the situation first. So this is a business situation, right? And here a company named JC Incorporation is actually buying a piece of land for $60,000 payment, which is to be made, is due each year for the next 5 years. So I am buying it on installment, है ना? So how much I have to pay? Every year I have to pay $60,000. Okay, so what is the situation? The question is, I want to learn, I want to know what is the present value of this stream, because I am paying in future, right? So you are committing today, you are in the loan agreement, in the agreement to purchase, you are committing yourself that okay, I will pay you 60,000 every year for next 5 years and give me this land today. Same happens when we get the housing loan. We take, okay, give me loan of 20 lakhs and tell me how much I need to pay every year, every month. Then they will calculate your, the bank manager, they calculate your amount of payment in every, installment, that monthly installment. So what they are doing, they are also using discounting. So it's very good that if we as a businessman, if we as an individual, we know that how discounting can be used, then nobody will befool you. They may say that it is on 12% loan, but actually when you calculate yourself, you will find it is on a higher side. It means they are befooling you, but it is possible only that if you test it, if you check it, and you can actually learn this today, that how can you calculate exactly are you charged 12% or not. So if you discount this 60,000 at the rate of 12%, how would you get the answer? So we have one table known as entry table for discounting, right? So if you go to that table, so present value table for annuity, we generally would have it as a T4, table T4 in most of the books. Even in foreign author books, it is the fourth table, because first table is compounding table for 1 rupee, then compounding of annuity, then we have discounting of 1 rupee and discounting of annuity. So, the 4 tables are there prominently in every book in this order only. That is why I am so confident saying it at table number 4. So, you multiply the factor, the annuity factor, which is 3.60205 at 12%, n is 5, and you multiply it with the 60,000, which is the payment, which is the annual payment you are going to make, and the answer is 2,16,000. So, you can actually to you that piece of land you need to see, is it worth of 2,16,000? Because you will think I am paying 3 lakhs. No, you are not paying 3 lakhs. You are paying 60,000 in future, and future has less value. You may think I am paying 3 lakhs today. I am committing for 3 lakhs, because you are actually not paying 3 lakhs today. You are getting something which is worth of 2,16,300 today, for which you are going to pay in installments in future, and that piece of land is worth of, so the value is 2,16,300, or other way around, the discounted value of the payments to, so your cost is 2,16,000. In better comprehension would be that my cost of that piece of land is 2,16,300 and not 3 lakhs, because you are going to pay in future. So, one way is to find out that annuity table. Another way is that if I can go to the discount value table of 1 rupee, and I take discount factors for all the 5 years and sum them up together and multiply it with the flow of cash. Even then you will get the total would be 3.605. So, that is how we get the answer or the present value of annuity. So, we have the formula where we multiply present value interest factor for given I and given n with the PMT or AMT. PMT or AMT is basically in Excel when we analyze or when we go to analyze function, or in financial calculator generally PMT or AMT word is there. So, is the amount, is the monthly amount or the amount of installment we pay. Right. So, we multiply that with the factor and we get the answer, that what is the present value of that annuity. So, PVA here. So, let us take up this example here, another one. If the interest rate is 14%, how much would you have to put in the bank today so as to be able to withdraw $100 at the end of each of the next 5 years? So, you want to take 100 rupees, $100 for every year, like from now for the 5 years, next 5 years, right. So, we are talking about the ordinary annuity, which is an annuity due, right, not the ordinary one. End of each year, for the next 5 years, I want to have I want to be receiving $100 from a bank, right. So, bank must pay me $100 every year end, and that they are paying 14% interest rate. So, how much should I put in the bank today? So, this is a case of annuity. How come? Because 100 rupees or $100 every year, right. So, amount is same every year, and the n is known to me, n is 5 years here, and it is a series of payment, it is not one payment which I am expecting, or one receipt here in this case, right. So, that is why it qualifies to be called as annuity. Okay. So, what we will do, we will multiply 100, which is amount, which is PMT or AMT here, with the factor. Where would we get the factor from? This is the abstract of a table I have just taken for your understanding here. The 14%, if you refer, because rate of interest is 14%, right. So, see 14%, we are going back to the table. At 14% for N5, the factor is 3.433, right. So, let us go to the situation here. We multiply the factor 3.433 to dollar hundreds, and we get the answer 343.30. It means if you deposit today 343.30 1.30 in the bank, you will be able to withdraw $100 every year for 5 consecutive years, right? So, I hope you were able to comprehend this situation. Same thing, if I have to go further, if I have to if I have to extend this further, if the interest rate is 14%, what is the present value of 100 to be received at the end of the third, fourth and fifth year? Now, here you are the series of payment, but you are getting more than once. So, here the two ways to solve the situation. One is that we take the factor 3.433 for 5 years and we subtract the factor for 2 years, which is 1.647, and we multiply that with the amount, which is 100, and the answer would be 178.60. Or other way around, for a single table, I mean the table for single rupee or single dollar, we can take the factors for 3, 4, 5 years, right, or third, fourth, fifth year, not because the question was third, fourth, fifth year. The factor would be 0.675 for third year, 0.592 for fourth year, 0.519 for the fifth year. We sum them up together, the three factors. The three factors together would make 1.786, the very much same which we did in the first solution. So, on the same slide. So, you multiply 100 with the factor, the answer will come the same, right. So, this is when we are discounting, we are discounting annually, but the its amount seems to be annuity, but we are not getting, we are getting after a gap of certain period here. So, let us take one more situation example. The XYZ company expects to receive 2 lakhs rupees for a period of 10 years from a new project it has just undertaken. Assuming a 10% rate of interest, how much would be the present value of this annuity? Company expect to receive rupees 2 lakhs for a period of 10 years. Every year 2 lakhs rupees are required, right, from a new project. So, it has undertaken. So, it's like that, we go for mining project, we go for installation of something, we go for example, the gas, the piped gas line, or supply of any such service, internet, supply of some. So, we have towers, if the towers are given for 10 years term, and the company expect I must earn 2 lakhs every year or every month, so that becomes annuity, right. So, company needs to know that from this project, if I undertake this project at 10% rate of interest, the current expected rate of interest is 10%, how much would be the present value of the future annuity, the future value I get every 10 years, right. So, this is thus another business situation. So, the appropriate annuity discount factor for 10-year annuity or 10% is to be found from the 10th row against the 10% interest column from the annuity. So, as I said, columns are indicating rate of interest and rows are indicating number n, and number of years n. So, the table will give you a factor at 6.145. So, we multiply this factor by the empty amount of 2 lakhs and we can find out the sum of the present value of annuity 12,29,000. So, how to comprehend this? Let me explain it to you. So, this is a business situation that you are entering into a new project, right. You are entering into a new project and you are going to get 2 lakhs rupees every year for the next 10 years, and you have to look into that how much, because every business project requires some investment from you, and you have, for that project only, you have to buy new machinery, you have to hire somebody. So, you have to look at the cost part. So, by comparing this inflow, which would be 2 lakhs for 10 years in future at 10%, you come to know that the total receipts are actually today worth of 12,29,000. It means at any cost your investment should be less than this, only then the difference is you would be your saving or your income, right. So, you would try to invest 4 lakhs, 5 lakhs, 6 lakhs, maximum 7, 8 lakhs depending on how much margin you want to keep. So, this will give you exactly a fair idea of the cost you can actually bear to carry this project, right. So, another example, same way, let us take another example, a limited company that borrows commercial from a commercial bank 10 lakhs rupees at 12%, and it is to be paid in equal annual end of year installments. So, what should be the size of installment assuming the repayment period is 5 years. So, here the situation, business situation is what, that I have to pay 10 lakhs, and I want to know the number of the amount to be paid every year. So, what we will do, we will take n years to 5 and n as 5, rate as 12, we will go to table, we will find the factor is 3.605, and if we divide 10 lakhs rupees, the commercial bank's value, with the factor, we will get the amount of the installment to be paid, right, 2.77 lakhs, 77,393. So, this is another application of this time value money concept in discounting precisely, and when we want to know the payment in annuity format, by using the annuity discount factor, by dividing the payment which we borrow or the amount which we borrowed today with the factor, we get the amount to be paid in future. Last thing here is discounting of a perpetuity. So, perpetuity is a situation very close to annuity. The only difference is the series of payments are there, the amount is same, interval is also same, like known to us, but what is not known is n. So, n is missing. So, its perpetuity means it keeps on. So, annuity which keeps on going forever is perpetuity, n is not known. So, here see, the amount is divided by I, and that is what gives you the answer of perpetuity. That is how we solve the perpetuity situation. So, in real life there are very few such situations, that is why it is kind of less in use. So, friends, with this I would like to wind up. We have covered discounting of annuity, discounting of perpetuity, discounting of uneven cash flow, and I have tried my level best to explain with the help of couple of examples. Hope that has worked for you. Thank you very much, friends.